Hi, grade 6. It's been almost a year now, well, about 8 months, since I recorded my videos about transformations, slides, flips, and turns, translations, reflections, and rotations. And everything I recorded in that video 8 months ago is still good information for you as you're learning how to do these things, especially because in grade 5, you only had to move stuff around predetermined boxes that were given to you, and you didn't actually need the coordinate plane stuff yet. That was a grade 6 concept even last year when I gave it to you. Now, we're using the coordinate plane, and we're doing slides, flips, and turns, again, translations, reflections, and rotations on that coordinate plane. Most of that should be pretty straightforward for you, but there's one extra thing that's really likely to trip you up. Now, rotations are still tricky. Rotations are not actually what I'm talking about, though, because while they're the most difficult of the 3 transformations, they're not any more difficult in grade 6. They're still just kind of tricky. Translations are just as easy as they ever were. What's going to be a little bit difficult, though, is that now, when you're reflecting, you're not just reflecting over horizontal or vertical lines. You also sometimes need to reflect across a diagonal. And reflecting across a diagonal is a little bit different and a little bit of a stumbling block. So as the new concept for grade 6, I'm going to make this extra video to show you how to reflect across a diagonal. Here we go. Okay, so here we see our coordinate plane with the triangle ABC written on it. Now the first thing we're going to need to do is name the line that we're reflecting across. And this is a little bit tricky with a diagonal. Now with a straight up or down line, we can name that line based on the thing that it's always going to be going through. So if I have a vertical line, let's just draw one for example. If I have a vertical line that goes through this point, but doesn't do that. Where is my select? There we go. If I have a vertical line that goes through here, then when x is 13, y is 1. When x is 13, y is 2. Here, x is 13, y is 3. X is 13, y is 4. X is 13, y is 5. X is 13, y is 6. All the way to x is 13, y is infinity. So I can just name this line based on the fact that the x never changes. And in fact, that's what I do. I would name this line x equals 13. Easy. Unfortunately, I don't get to do that with a diagonal because the x and y change with each other as we go. So here, when x is 3, y is 0. When x is 4, y is 1. When x is 5, y is 2. When x is 6, y is 3. When x is 7, y is 4. When x is 13, y is 10. Now, if you remember our input-output tables from earlier in this year and how to name these lines, well, we're just going to name the line that way. But we need to recognize the relationship between x and y here. In this case, my x is always going to be 3 more than my y. So if I have x and take 3 away from it, I get y, which is why I call this line y equals x minus 3. No matter what my y is, it's going to be 3 less than my x on this line. X is 3, 3 minus 3 is 0, y is 0. So x is 3, y is 0 is on that line. X is 6, 6 minus 3 is 3, so x is 6, y is 3 is on that line. X is 13, 13 minus 3 is 10, so y is 10. X is 13, y is 10 is on that line. Everywhere on that line can be shown by whatever my x is, my y is 3 less than it. Now again, that should hopefully be a review of some of the input-output graphing we did earlier this year, so I'm not going to dwell on it. but that's how we name what we're reflecting across here. Our task today is to reflect the triangle ABC across y equals x minus 3. That's a lot of letters thrown at you, but hopefully in a way that makes sense, because now we're going to do it. Now first I'm going to show you what not to do. This is a very common mistake when people start out here. So don't do this. But what you've done so far is when you're making a reflection, you're finding the line, you're finding how far the thing is from it, and you're moving it the opposite direction, but the same distance. So for point C, for example, C is 1, 2, 3 away from my line. So C prime should be 1, 2, 3. I'm going to move this out of the way. 3 away from my line. This should be C prime. B is 1 away from the line, so B prime should be 1 away. And A is 1, 2, 3, 4 away, so A prime should be 2, 3, 4 away. Now if I connect these dots, hopefully you're going to realize pretty quickly. Now this is not a reflection. In fact, it's not really anything. I've just kind of deformed my shape. And the problem with this is, I'm not sure which direction I'm going. Because this is a diagonal line, I would be just as correct doing this left to right as I would be going from up to down around the line. Let's see what that looks like. C is 3 above, so C prime should be 3 below. B is 1 above, so B prime should be 1 below. And A is 4 above, so A prime 4 below would be 1, 2, 3. It would be at -2, so off my screen. That triangle then, I'm going to try and approximate where A would be without drawing it, because we're only working in the positive quadrant right now. That triangle would end up looking kind of like this. Again, that is clear, and it would continue on, and eventually those two lines would connect, hopefully around -2. That triangle looks nothing like the triangle I started with, and pretty clearly, neither one is a reflection. So, what the heck do I do here? Well, we're about to do it. Now, if I can't just move left to right, or up to down away from the line, what can I do instead? How can I make this work? Well, the important thing to remember when you're reflecting across a diagonal is that left becomes different. It doesn't become right. Depending on which way the line is going, it could become either up or down, but horizontal is going to become vertical. Whatever distance it is away, it's going to be the same distance away, just like a regular reflection, but all of your horizontal differences are going to switch to vertical differences. That means that since my C is 1, 2, 3 away, my C prime is still going to be 3 away. But it's going to be 3 away on the opposite side of the line, either up or down. Since up would keep it on the same side of the line, this time left is going to become down. So C prime is 3 down from the line because C was 3 left of it. B is 1 to the left, so it's going to become 1 down for B prime. And A was 1, 2, 3, 4 to the left, so A prime is going to be 1, 2, 3, 4 down. 1, 2, 3, 4. Yes. Remembering how to count is important. Now, if I connect those dots, it should be a mirror image on the diagonal of the triangle I started with. Let's get our line tool and connect them to double check. There we have an actual mirror image, an actual reflection across the diagonal of what we started with. Now remember, it's always going to be the opposite of the line. So this isn't quite as complicated as in a rotation, where you have to remember that, turning left 90 degrees clockwise means left is up, down is left, right is down, and up is right. It's not quite that bad. You only have to remember one direction each way. Because in this case, if I went up from the line instead of down from the line, I'd still be on the same side of the line. It wouldn't be a reflection. So left, in this case, everything's to the left, so everything will be down. I just have to remember left becomes down. Not too bad. Let's try one the other way, showing how it works if the diagonal's going the other direction. Okay, now in this case, naming this line that we're reflecting across is a little bit tricky because it requires the use of integers. So I'm not going to expect you to name a line like this in grade 6. This is more grade 7 or 8 level, but I'm still going to show you what I would call it so that you're aware. Now, when a line slopes down and to the right, the x is actually usually going to be negative. Y equals negative x, plus or minus something in this case. So in this case, when y is 10, x is 0. When y is 9, x is 1. When y is 8, x is 2. X is still going up as y goes down. Now that means that my x, so my y, is going to be negative x plus 10. Negative 0 is 0. There is no negative 0. Plus 10 is 10. So 0, 10. Negative 1 plus 10 is 9. When x is 1, y is 9. Negative 2 plus 10 is 8. When x is 2, y is 8. Negative 3 plus 10 is 7. When x is 3, y is 7. Whatever point you go on this line, if you take the negative of the x and add 10 to it, that'll be where y is. Again, that's way past grade 6. You don't have to worry about being able to figure that out on your own, but it is a thing. That's how we name this line. So this line is y equals negative x plus 10. I am telling you this just so we have a name for the line, not expecting you to ever be able to find this at this point on your own. However, reflecting across this line is something you should be able to do. So let's take a look at it and do this the exact same way we did the other reflection. Now, in this case, A is 1 away from the line. We can look at that as A is 1 up, or A is 1 right. Well, that means that 1 up or 1 right from the line should be still 1 away, but whatever the opposite is. Now, I just need to choose one and stick with it here. If I want to use right, that's okay. If I want to use up, that's okay. My reflection will actually end up the same, as long as I keep myself consistent. So, since A is 1 away, let's go with up. A is 1 above the line. Well, I need to then choose left or right, because when you're flipping on a diagonal, horizontal becomes vertical, and vertical becomes horizontal. Since I'm vertical, I need to now move away horizontally. Well, if I move to the right, I'd be here. And that's on the same side of the line. I didn't flip across the line if I'm ending up on the same side. So I can't move right. Right is out. Instead, I'm going to have to move 1 to the left. A prime is here. B is 1, 2, 3, 4 up. Now, since it's up right now, it has to move either left or right when I'm flipping diagonally. If I move 4 right, B prime would be on the other side of the line, would be on the same side of the line that I started on. I can't be on the same side of the line if I'm reflecting. So that's not the one. Instead, I've got to go 4 left. 2, 3, 4. And B prime should be here. How about C? Just get these dots out of the way because it makes things a little confusing. How about C? C is quite far away, actually. It's 1, 2, 3, 4, 5, 6, 7, 8 above the line. 8 to the right would be all the way off here. And again, that's on the same side of the line, so it can't be 8 to the right. Instead, it'll have to be on the other side of the line, which is 8 to the left. 1, 2, 3, 4, 5, 6, 7, 8. Here's my new C. Erase the dots just because they make it look messy. And let's connect them up. And there we go. We have reflected ABC to A prime, B prime, C prime across the line which I have given you the name of and would never expect you to find the name of in grade 6, y equals negative x plus 10. This is our reflection. All you need to do is remember that vertical and horizontal switch places when you're reflecting diagonally. And you need to be on the opposite side of the line. So if you turn right into up, say with this C, let's go with this A. If I turned right into up, well, I'd be on the same side of the line. But if I turned right into down, I'd be across the line and the same distance away. If I turned right into up, I'd be on the same side of the line, and I can't do that. So I turn right into down. And I have reflected across that line. Let's clear all this. Okay, I hope that that makes sense. Reflecting on the diagonal is actually not that difficult. You're still moving the same number of spaces away. You just need to remember up and down turn into left and right. Left and right turn into up and down. You're always the same distance away, and actually cross the line when you're drawing your prime corners. Because if you don't cross the line, you're not reflecting. Okay, that'll do it. Now, reflecting across the diagonal isn't that different from reflecting across a horizontal or vertical, but it is different enough that it can be a hang-up for you. So I hope that that clarified it. I hope that that makes sense. Please, please, please remember, left and right aren't just left and right when you're reflecting diagonally. Horizontal becomes vertical. That's important. Keep that in mind when you see a diagonal line and you're asked to reflect across it. Otherwise, pretty much the same stuff. Not too hard, but just different enough that it can trip you up. And that's it. Have a great day, grade 6. Peace.